everyone, I'm Pavi, I'm 15, and over the past few months, I've looked really deep into nanotech. Now, for a while, I looked at nanotech in healthcare, and then I came across this one article about counterfeit products. My eyes went wide, and I became so excited. Now, counterfeit products, we all probably have heard about them here and there, but we don't really know much about them. But over the past 2 weeks in specific, I've read over tens and dozens of research papers about counterfeit products. You know, other than reading research papers, I'm also an avid shoe lover. I love Jordans. I mean, you can clearly see them on my feet right now. These are Jordan Retro 4s. I mean, I can go on and on about shoes, but I really want these shoes. They're roughly like $300 from the websites that I've seen. But one time, I saw a website that showed them for $70. I kid you not, I ran downstairs, I was so excited. Until I actually looked at them. The brand was weird, the colors were faded, and it just looked really odd. So then I was like, okay, this is a fake. And then I started to play games and decided, okay, can I tell which shoe is real and which one's fake? So I'm gonna ask you guys, which one do you think is real and which one do you guys think is fake? Just shout it out.
Left is fake. Right is fake.
Okay, we got some right is fake, we got some left is real. You guys are a very smart audience, you guys are correct. So the left one is, and the right one is actually real. But if you actually look at them, you can't really tell. Now, if I were to buy the fake Jordans, I don't think I'd honestly really realize. They're just shoes, it's not a big deal. But this actually happens in so many different products, like credit cards, or access cards to Sensei Labs, or even pharmaceutical pills. Now, especially in Canada, over the past few weeks, counterfeit products have been taking control. In fact, counterfeit products are reaching their epidemic level. More specifically, just last week, 20.4 million fake pharmaceutical pills were sold as counterfeit. Now, you might not actually understand what that means. But typically, when we go to the doctor and we get medication, the pills have active ingredients in them. These active ingredients help us, relieve our sickness. But when they're fake, they have no active ingredients, and people actually die from this. Now, a lot of people have digital fingerprints and digital IDs through 5G and IoT. But if we really think about it, if we were able to make these into quantum IDs, they would literally change how we look at the authentication system. So I think a lot of us have heard about the word nanotech or nanoscale here and there through this presentation alone. But I want to actually put this into perspective. If you have one of your hair strands, that is roughly 50,000 nanometers in length. Or, here is an eye exam. I hope you've seen this at least once. But if you look at the last label, it might be a little bit hard to see, especially for all of you at the back. Now, think of it as the last scale, but think of it as like 10 times smaller. Or 10,000 times smaller. That is the nanoscale. It is so tiny. That means that everything we look at is at the atomic scale. So we look at atoms and everything that they have to do. Now, if we're able to take these digital IDs on the atomic level, we can make physically unclonable functions, or puffs. What puffs do is they take an input based on atomic arrangement or atomic imperfections. They end up creating a challenge and response pair, or an input and output value. When they do that, you can then authenticate it, and there you have an unclonable system. A little bit more about puffs. What we can do is you can have a unique arrangement of atoms, and in all these nanostructures, if you harness them, then you can create an unclonable system. For example, if you look at that one little diagram in the corner, if I take the middle atom and move it to the top, I create a completely different atomic composition. That creates a new arrangement of atoms and a new authentication system. Now, it's also based on atomic randomness and different imperfections in nanostructures. And they are mass-produced using one of the most common materials in nanotech, meaning they're pretty viable. Now, I talked a lot about atomic arrangement, and you're probably like, okay, I get it, atoms are small, there's a lot of them, but like, how do they actually work? Let's say I had 2 buckets of sand. I take one of the buckets, and I pour them on the floor right over here. We're gonna call this configuration 1. I decide, okay, I'm gonna make this a little bit hard for you guys, I'm gonna go step on the sand. So now you have my own Jordan footprint in the sand. Now let's say I take another bucket of sand, I pour it on this side, and I say, okay, I want you to replicate this exact configuration with this bucket of sand. And I'm gonna give you guys 1 week to do this. In your head, you're probably like, okay, Pavi, that's like no challenge, it's all easy. What if I told you that every single sand grain, every single one of them, had to be the exact same as the first configuration? That means everything at the atomic level has to be identical. Keep in mind, there's like trillions of atoms. Okay, now I see you guys are looking at me and I know that you think I'm crazy. This is exactly what I'm talking about. If we think about every single grain of sand and replicating them, think of those as atoms. Think about replicating trillions of atoms. Practically impossible. And that's what's great about these puffs. Now, another thing is we can look at imperfections. On the right, we have a quantum well. So everything in the center, these little blue sections, they're the imperfections in atomic nanostructures. So if we can harness those or change imperfections around, you can create again an unclonable puff. For example, here is a patented version of this, and all of the section around that little square, these are hundreds and thousands of different atoms. So if we were to change one of them, you'd create, again, a new puff. Now what's really great is we can actually use this with graphene. So we all know graphene is like this really cool 2D nanostructure. So what you can do is you can take these imperfections, you can shine a light on them, and you're given signals. These signals can be turned into a number sequence, which are then the quantum fingerprint. More specifically, this all has to do with quantum physics. Now, electrons and photons, they don't follow the normal law of physics. They follow something known as quantum mechanics. Now, I'm going to be honest, quantum mechanics are pretty cool. Let me give you a little demonstration. Hands up if you've ever played the game Floor is Lava. Oh yeah, it's a childhood favorite. Let's say that this entire middle section was the lava. My whole objective is to get from this side to that side. Now, what you can actually do is I have two options. One, I could become like Superman and fly over to the other side. Let's say I get a state of 1 through flying over. Or I can put a chair in the middle of the room, step on that chair, and then step to the other side of the room. That would give me a state of 0. Now that's exactly what I'm talking about when I'm talking about quantum physics. For example, here we have a diode. Picture that little blue electron to be me. Now if that electron, we have this hashed area, which is going to be the lava. So if we take that electron, either it can jump that hashed area, get a value of 1, or it can go on a stepping stone and get a value of 0. When this happens, all these zeros and ones are measured, and you get a random stream of zeros and ones known as the input. If you were to input these into puffs, you'd get the output, which is the key. Now, what's really great about these challenge and response pairs is that if you have two different puffs, you can put the same challenge and get different responses. So no matter what, they're very, very unclonable. Now, quantum fingerprints are actually more unique than DNA. For example, I talked about the atomic arrangement. Think about harnessing and changing thousands and trillions of electrons. That would be difficult. Now, what if I told you had to try to replicate imperfections in graphene? That'd also be difficult. Or what if I told you had to copy CRPs and these challenge response pairs and all these zeros and ones? That'd also be difficult. That makes them a lot more unique than DNA. In fact, if we were to actually have to measure these input and output values, it would be much longer than the age of the universe. So no one would actually be able to do this. Keep in mind, this is all relating to quantum physics. Now, counterfeits have been taking a surge, but if we can use these nanoscale puffs, they will honestly not have the counterfeit goods will not be able to reach the epidemic level that we're heading up to. Thank you.